In 1977, two small machines departed from Earth, assigned to a task far simpler than what they would ultimately become. The proposal was almost bureaucratic: a 5-year mission, a careful analysis of Jupiter and Saturn, the collection of data, a few historic images, and after that, definitive silence in the void. Nothing beyond that was in the plans. No one anticipated that these artifacts would reach the edge of the solar system, much less cross into interstellar space. And yet, a rare planetary alignment opened a narrow cosmic window, allowing Voyager 1 to harness the gravity of the gas giants like a natural slingshot, leaping from world to world and accelerating far beyond any initial expectations. But before we begin, don't forget to like this video and subscribe to our channel. Along its trajectory, it revealed colossal storms larger than Earth, oceans hidden beneath frozen crusts, moons that appeared tranquil yet concealed intense activity, and ultimately encountered an invisible and abrupt boundary where the sun's influence ends in a surprisingly well-defined way. With technology less powerful than a common household light bulb and memory smaller than a modern notification sound, Voyager 1 kept moving forward. It crossed a limit no human-built object had ever crossed and began detecting something that had never been observed before. What it found was not merely distance, but structure, pressure, sound, and physical boundaries. And that encounter would quietly redefine where our world truly ends. Voyager 1 was never designed to become a pioneer of deep space. When it launched in 1977 alongside Voyager 2, its mission was clear and limited: travel to Jupiter and Saturn, study them up close, and then conclude its journey. The opportunity for this extraordinary route emerged thanks to a rare planetary alignment that occurs roughly once every 175 years, placing Jupiter, Saturn, Uranus, and Neptune on the same side of the Sun. This arrangement allowed the spacecraft to use each planet's gravity as a gravitational assist, successively leaping from one world to another in what NASA named the Grand Tour. From the beginning, the sequence of launches already suggested that something unusual was underway. Voyager 2 launched first, but just 16 days later, Voyager 1 was sent on a faster trajectory and soon overtook its twin. Only 13 days after leaving Earth, already more than 6.8 million miles away, Voyager 1 turned its cameras back and captured an unprecedented image: Earth and the Moon together, seen from deep space. A distant family portrait in which our planet appeared as a tiny blue dot suspended in the dark vastness. Even at this early stage, the mission exceeded its technical objectives, transforming scientific goals into images that forced humanity to see itself from the outside. When Voyager 1 approached Jupiter in early 1979, it encountered a world very different from what had been imagined. A giant planet wrapped in violent storms, intense radiation belts, and a complex system of moons behaving like a miniature solar system. During its flyby of Jupiter and later Saturn, Voyager 1 made discoveries that reshaped planetary science, revealing thin rings, unknown moons, and extreme environments that no telescope on Earth could have predicted with precision. The most critical decision came at Saturn, when a close flyby of Titan was chosen, allowing a detailed analysis of the thick atmosphere of this mysterious moon. That choice came at a cost. Saturn's gravitational assist sharply redirected Voyager 1's trajectory out of the plane of the solar system, eliminating any possibility of visiting other planets. From that moment on, its mission changed forever. It ceased to be a planetary explorer. It became a boundary breaker. Accelerated to become the fastest spacecraft ever built, Voyager 1 was sent on a one-way journey toward the outer limits of the Sun's domain, heading directly into a region no human technology had ever crossed. When it reached Jupiter, it did more than observe a planet. It dismantled decades of assumptions in just a few days. What from Earth appeared to be a distant gas giant revealed itself as a violent and complex world, surrounded by massive storms and an intricate system of moons. Voyager 1 captured images that revealed thin rings whose existence had been unknown, as well as new moons, later named Thebe, Mates, and Adrastea, transforming Jupiter from a familiar object into a dynamic and evolving system. The Great Red Spot, visible for centuries through telescopes, was finally observed up close and confirmed as a colossal counterclockwise storm larger than Earth, an atmospheric monster active for centuries. But the real shock came from Io, Voyager 1. 1 detected active volcanoes erupting on this small moon, marking the first time volcanic activity had ever been observed beyond Earth. Io was not a frozen or inert world. It was violently active and remains the most geologically active place in the solar system. Then came Europa, with its smooth, cracked, icy surface, suggesting something even more extraordinary below. The images indicated the possible presence of a vast subsurface ocean hidden beneath miles of ice, quietly introducing the idea that one of the most promising places to search for life might not be a planet, but a moon orbiting a distant giant. After Jupiter, Voyager 1 used gravity itself as a tool, accelerating towards Saturn and arriving in 1980 with unprecedented momentum. Saturn, once considered elegant and simple, revealed a surprising level of complexity. What had appeared to be a single thin ring turned out to be hundreds, even thousands, of narrow and intricate structures, dynamic and constantly interacting. Voyager 1 also discovered 4 new moons, including Mimas, whose enormous Herschel crater makes it resemble a Death Star lost in space. The most important encounter, however, was with Titan, Saturn's largest moon and the only one in the solar system with a thick atmosphere. Although its surface could not be seen due to atmospheric opacity, analysis of its composition revealed something extraordinary. Titan is so cold that methane exists there the same way water does on Earth, in solid, liquid, and gaseous states. This discovery paved the way for the idea of lakes and rivers far from the Sun, transforming our understanding of planetary chemistry and habitability. The close approach to Titan, however, definitively redirected Voyager 1 out of the plane of the solar system. After years of silent travel, Voyager 1 reached a region where definitions fail and boundaries exist without visible lines. On August 25, 2012, its instruments detected something extraordinary: a sudden drop in charged particles coming from the Sun, and simultaneously, a sharp increase in high-energy galactic cosmic rays. It was not a gradual transition, but an abrupt shift, as if the spacecraft had collided with an invisible wall. Voyager 1 had crossed the heliopause, the boundary where the solar wind ends and interstellar space begins. The Sun's protective bubble, the heliosphere, ended suddenly, forming a frontier where solar plasma collided directly with interstellar plasma. In that instant, Voyager 1 stopped traveling through space shaped by the Sun and entered a domain governed by the galaxy. For the first time in history, humanity had physically reached beyond the influence of its star. More than 15 billion miles from Earth, Voyager 1 recorded a persistent cosmic hum around 3 kilohertz that lasted nearly 3 years. Described as a thin metallic tone, as if the universe itself were vibrating in the background, this signal was interpreted as interstellar plasma waves, allowing scientists to measure the density of the space between the stars. At the same time, the data showed that the interstellar magnetic field was 2 to 3 times stronger than previous models had predicted, exerting pressure on the heliosphere nearly 10 times greater than expected. This revelation showed that the solar system exists within a compressed bubble, shaped by the galaxy around it. Voyager 1 backward. also helped confirm that the Sun resides within a vast region known as the local bubble, a cavity about 1,000 light-years across, carved by ancient supernovae, which alters how cosmic radiation reaches Earth. What Voyager 1 found was not emptiness, but structure, force, and sound. Proof that even beyond the Sun's influence, space is active and dynamic. When it was already tens of billions of miles from Earth, everything inside it should have stopped working. Its computers had less than 70 kilobytes of total memory, an amount so small that even a modern notification would surpass it. Scientific data were still recorded on 8-track magnetic tapes, technology now confined to museums, and the radio transmitter sending signals back to Earth operated with only 22.4 watts, roughly the power of a light bulb inside a refrigerator. And yet, this fragile combination of outdated hardware continued to function in an environment where temperatures approach absolute zero, and cosmic radiation continuously damages electronic components. All of this was sustained by 3 radioisotope thermoelectric generators, which slowly convert the heat from the decay of plutonium-238 into electricity, weakening year after year, yet still providing enough power to keep the most critical systems active. Engineers had already shut down most of the instruments to conserve energy, knowing the end was approaching. And even so, Voyager 1 kept moving forward, carrying with it humanity's final gift. The Golden Record, a small disk containing images of Earth, greetings in 55 languages, sounds of nature, music, and fragments of what it means to be human, traveling silently through the interstellar darkness. As the spacecraft aged, its problems became impossible to ignore. On November 14, 2023, Voyager 1 suddenly stopped communicating in any intelligible way, transmitting streams of meaningless binary data, digital noise indicating that something deep within had failed. Engineers traced the problem to a memory fault in the flight data system, one of the spacecraft's most critical components. Giving up would have been easy, but the NASA team decided to attempt something extraordinarily risky, rewriting and relocating decades-old code into the remaining healthy sections of memory, a procedure that required surgical precision, patience, and courage. Each command sent to Voyager 1 took 22 hours and 30 minutes to arrive, and another 22 hours and 30 minutes for the response to return, meaning that a single attempt consumed nearly an entire day of waiting. This tense process began on April 18, 2024, followed by days of silence that pushed nerves to the limit. Then, on April 20th, Voyager 1 spoke again. Engineers described the moment as watching the heart of an elderly traveler of space begin to beat once more. Voyager 2 had faced its own crisis months earlier, when a seemingly minor command caused its antenna to shift just 2 degrees away from Earth, a minimal error that nearly caused it to vanish forever, until a powerful signal transmitted from Australia re-established contact after 37 agonizing hours. These episodes revealed the true essence of the mission's resilience. The Voyagers were not merely machines. They were aging explorers, fragile and stubborn, pressing forward even as their voices grew fainter, proving that long after the deadlines imagined by their designers, they were still out there, still responding, still carrying human curiosity into the darkness. Voyager 1 did not collide with any physical object in deep space, but what it encountered may have been even more significant. It reached an invisible limit, crossed a boundary that announces itself with no walls or markers, and entered a region where the rules change silently. Beyond the heliopause, Voyager 1 revealed that space is not empty, nor silent, nor passive. It found pressure where we expected freedom, structure where we imagined emptiness, and a constant cosmic hum where we had presumed absolute silence. It showed that the solar system exists within a fragile bubble, compressed and shaped by forces far older and more powerful than our sun, and that even the space between the stars has texture density, and sound. All of this was discovered by a machine that was never meant to survive this long, powered by less energy than a household light bulb, guided by computers simpler than many modern toys, and yet capable of expanding humanity's understanding of where we truly are. As Voyager 1 continues its journey toward the distant regions of the Oort cloud, a journey that will take centuries just to begin and tens of thousands of years to complete, it carries something far more important than instruments or data. It carries a record of us, our voices, our music, our images, and the silent declaration that we were here, that we wondered, and that we dared to go beyond our limits. Whether anyone will ever find this message is almost irrelevant. What matters is that we sent it. Long after the last signal fades and silence finally prevails, Voyager 1 will continue moving forward, a small fragment of humanity traveling through the darkness on our behalf. And perhaps that is the most extraordinary encounter of all, the moment we realize that even in the vastness of deep space, we are not merely observers of the universe, but participants in it. If this journey changed the way you see the universe, tell us in the comments. And if you want to keep exploring the limits of what we know, don't forget to like, subscribe, and follow the story of the most distant travelers humanity has ever created.